Hi everyone. I'm going to go ahead and do the match pair t-test example. So let's take a look at the problem. It says, is a person's pulse rate higher when they are standing than when the person is sitting? To answer this question, a group of 14 students measured each other's pulse rate in both positions. The data collected are given in the table below. Consider this to be a random sample taken from a population in which the difference between these two pulse rate measurements is normal. I went ahead and I highlighted the important things we're going to need when we're checking our conditions. So the first thing is a match pair t-test usually is done with a before and after situation, or when we want to pair our data. So let's take a look here. We are actually given two lists. The pulse rate sitting, so this is 14 students' rates were recorded when they were sitting, and then the pulse rate for the same student was recorded when they were standing. And if you look at what I highlighted before, the difference row, that was taken, and you can see that looking at that, it is taken by doing the difference of 68 minus 62, that's 6, and 78 minus 74 is 4, and 80 minus 82 is -2, and so on. So we're actually going to do a t-test on the difference, which I highlighted. So that's the first thing to understand. Once we do that, then we're really just doing a t-test. So a match pair t-test is actually a t-test where we are taking the difference of the two measurements. So the first thing I'm going to do is I'm going to enter this list that I highlighted into the calculator. And so I went ahead and did that ahead of time. So the list is entered in my calculator. There are 14 measurements, like the difference. Sometimes you will not be given the difference and you will have to take the difference on your own. So the first thing to do is to write our hypothesis statement and define our variable. What are we doing? We're taking the mean difference. So here highlighted in green, it's also important to note I wrote standing minus sitting because it could be done the other way around. And so notice that the difference is standing minus sitting. I wrote that down. Now in our hypothesis statement, the null basically always is there's no change, there's no difference, it is the same. In this case, the difference between standing and sitting is 0 because there is no difference. So the first thing I'm going to do is I'm going to write that the mean difference right here is equal to 0. And then the alternative, I took that from the actual paragraph because it states in the paragraph, is a person's pulse rate higher when, right here it says, is a person's pulse rate higher when they are standing than when they are sitting? So that's where I took my alternative hypothesis, and that's going to be if it's higher, that means it's greater than. So the alternative hypothesis, meaning the mean difference, is going to be greater than 0. So that you need when you're entering into your calculator. So going to the calculator, I'm going to go ahead and just open a new page. And then I will do a matched pair t-test. So when I go to menu, statistics, stat test, notice it's not going to say matched pair. It's going to just say t-test. So I'm going to go up to t-test and number 2. And then we entered a list, which is our data. If they give you statistics, meaning they gave you the mean and standard deviation, then you could use statistics. But I'm going to keep it as data. And then you could see here you're given 2 options. So I'm going to stick to data because I entered a list. And now this is going to ask me, what is the mean difference? The mean not here is the mean difference. We are saying it's always the null that we enter first, which we're saying is there is no difference, so it's 0. The list is what I named it. I just named it difference. You could name it anything you like. And the test we're actually going to do is a greater than. So that will be the first one. In other words, that the alternative is greater than 0. So going to that, here are my results. And you can see from here, I get a p-value. I get the mean is 2.5. Now, obviously 2.5 is greater than 0, but is it significantly greater than 0 is what we should be asking. So our t-score right here is 1.56, and our p-value is 0.07, which if we compare to our significant level of 0.05, is a greater p-value. So just based on these results, we will fail to reject. In other words, we do not have sufficient evidence to state that the difference between standing and sitting is greater than 0. So now we just need to write it all up, and I will show you how to do that. So once we have our hypothesis statement, we're going to go ahead and state our conditions. Now, the conditions are still the same. We are going to first make sure this was a random sample, and it is stated in the problem that it is a random sample. So that's the first thing I'm going to check off, that it was stated random sample. It also stated that the measurements was normal. So that helps us in our second condition. We don't need to graph or show a normal probability plot because it is given, or it is stated in the problem, that it is normal. So the second condition is met. The third condition, we're going to say that the population is greater or equal to 10 times n. So our sample size is 14. 10 times 14 is 140. And we will say there are more than 140 students in the population. Always state what you will do. In this case, we will say conditions met. We will do a match pair t-test. Moving along to the mechanics. You should always write the formula in words. So I have the formula right here in words. So test statistic is equal to statistic minus parameter divided by your standard deviation of statistic. I went ahead and I placed the symbols as well. So our test statistic is T. Our statistic, which we want, is our mean sample, which is right here given on the calculator as 2.5. Now the mean difference, that is what we wrote in the null hypothesis. We said it was 0 right here. We said that the mean difference is equal to 0. In other words, there is no difference between standing and sitting. So when we plug in our values, we have the mean is 2.5 minus 0, that's our population parameter, divided by the standard deviation given here, 5.98, all over the square root of our sample size, which is 14. Now, you do not have to calculate this in your calculator. You can just use your calculator output here. It says that the t-score is 1.56. You could check your work and say 2.5 divided by all of this denominator will give you 1.56. Always state the degrees of freedom. In this case, it is our sample size minus 1. So 14 minus 1 is 13. And from there, we're going to write our p-value, which is 0.071, given here from our calculator output. We're going to write our significant level, which is alpha equals 0.05. Remember, that was given at the start of the problem, but if you are not given a significant level, you use by default 0.05, and you should write it down. And from here, we are going to state our conclusion, which is we failed to reject the null since the p-value of 0.071 is greater than alpha equals 0.05. So the first sentence always talks about the null hypothesis. It's either you fail to reject or you reject. So in this case, fail to reject. And we have insufficient evidence. We have insufficient evidence that the person's pulse rate is higher when standing than sitting. And that basically concludes this problem. The second part asks, explain why the design of this experiment is better than having two separate treatment groups, with one group of students measured while sitting and the other group measured by standing. One way you could respond to this, and there's several ways you can say something that would be just as well as what I wrote here. I wrote the same person before and after would reduce the variability of having a significant difference than taking two different groups. Match pair offers a better control of the results. This eliminates confounding variables that exist due to differences between people. All right, so hopefully this was helpful. I'll see you in the next video.